Sure.
But I've been having fun asking each of our speakers before you give your talk, what does it mean to you to be a quality programmer? What does that mean when you hear a quality programmer? How would you define that?
Yeah, that's a good point because now I remember the thing that I've missed to prepare.
Ah,
So I need
that's
to
okay.
improvise. Yeah, quality, I mean, quality work in general. So try to stick to the deadlines, really think about clean code, try to communicate well. Also, of course, testing is, of course, also an important issue. So all those things, I see it more as a package and not just of a single thing. And it's not only about technical abilities, but also social skills that are
Right.
also necessary. Like,
Yeah.
yeah, you want to have a good product, and then you also, in your behavior and the way how you work, you have to reflect that as well. This is what I
Yeah.
would say.
I love that. I've heard you give some presentations and kind of discuss that before, and I think you're exactly right. It is more than just technical skills. So, okay, well, I will turn it over to you, and
Okay.
yeah, looking
Okay.
forward.
Good. So I hope you can all see my screen.
Yes.
Wonderful. Good. Then also from my side, hello and welcome to my talk. Refactoring in Angular. I tried to come up with a very compact content. It's not so much time that I have there. And it's also for the first time that I do a talk about refactoring. So also excited about this opportunity. So maybe a little bit of introduction of myself. So I'm Rainer. I come from Austria and I'm part of Angular Architects. So we provide consulting and training workshops in Angular, obviously. I'm also GD and I also am active in the Angular community. So I have a YouTube channel. I also do an Angular newsletter, which is called ng-news. And if I have time left, I also try to participate in one of the existing open source applications or projects which are out there. So before we start, a little bit about the why refactoring. I think that is important. Depending on which kind of books you read, depending on which kind of blog articles you read, and so on and so forth, there are different reasons. I've just here picked some of them where I think all of us can find themselves. So you could say it's maybe more or less about gaining more performance. Maybe that's not what I would say. I would say maybe improving readability, improving maintainability, more or less about that stuff. But there are different reasons why you want to do a refactoring. And I would say in the end, what it should really do is, in a way, we want to reach better code, whatever context that means. And I think the addition of that, the application's behavior should not change. That's crucial. So we change the code, but to the outside, to our end users, the application should still be the same, but we end up with the better quality of our code, whatever that means for you. Good. About refactoring. So as I said, I try to think a little bit about how I would approach this kind of topic of refactoring, how I would do it. And I would say there are always three steps involved. So first of all, obviously, I need to be able to identify what I want to refactor. That depends on which level I want to do the refactoring. We will come to the levels afterwards. Then, of course, comes the implementation. And at the end, as I said before, the application needs to behave in the same way as before. And this is something we also have to verify, of course. And this is where testing plays a huge part. Now, about the different levels. So I would say, well, there is a refactoring which we could apply on a file level basis. So we have multiple files, and I say, yeah, there is a file, maybe there's just a function in it, and I want to improve now this function. So the very basics of refactoring on a file level. What we also have is an upper layer where we say we should try to group our files into different modules. There should be some dependencies between them. Of course, also a little bit of an encapsulation. And this is what I would call the maybe not module level refactoring, but maybe refactoring towards modularity. So this is this kind of refactoring that I'm talking here about. And then, of course, you also have the the huge refactoring which happens on an application level, where I say I'm going to restructure my complete code base in a certain way, and this will have a huge impact. And this is, of course, a completely different thing than compared to a file level. There is also the process will be a little bit different. We cannot use the same metrics, and also the testing will be different. So these are the three levels. And first, we'll start with the file level. In my opinion, that's the easiest one. And well, I have listed here for the identification process some metrics. And if you look into literature, if you research a little bit, then you very often stumble upon that cyclomatic complexity. And this is the one that I want to pick out a little bit and show what it means. But in general, we also have a cognitive complexity, which is an improvement, or at least that's what SonarQube is saying about it. I will say a little bit about that afterwards. Then maybe lines of code, where we say there should be a limit in the lines of code we want to have per function, code duplication, kind of identifying these things. And in general, we have to say a lot of those metrics, a lot of these kind of identifiers, whatever you want to call them, they are already available if you just use ESLint. So you just need to install it, you need to set it up, and that's it. ESLint and Angular is also an interesting story. First of all, ESLint is made primarily for JavaScript, and there is then TypeScript ESLint, which gives the ESLint the possibility also to pass TypeScript. And then there is also Angular ESLint on top of TypeScript ESLint. And we are in a lucky position because the innovator of TypeScript ESLint is also the one which is responsible for Angular ESLint. So that's quite a person who is quite knowledgeable. He knows how ESLint works in and out. And if that person also cares about the Angular ESLinting rules, as I said, you're in a very good position. Now, we will not go through all of through the metrics, but I just want to pick out this cyclomatic complexity because it shows up so often. It's a very old metric. It comes from the 70s by Thomas McCabe or McCabe. I can't pronounce it. I don't know how to pronounce it. But the way how it works is that it counts the different branches that we have within a function. So it's really related to on a function level. And it says, if you have an if-else, then your code can run through two different branches. And that's why the cyclomatic, the value of this metric would be 2. If you add an else if, then you have already 3. And the more branches you add in your function, the more complex it becomes, obviously, and then also the higher the rating that you have. And the cyclomatic complexity is something we have available in ESLint. So as I said before, quite a lot of tools, metrics are available already. Some are already activated by default. I mean, there are Angular schematics for that. But for the cyclomatic complexity, I think it's disabled by default. So you have to enable it. And I'm going to show you how this would look like. And then you can then just think about the other metrics that you need to do it in the same way. So I have here an Angular 17 application, which means I'm running ESLint, which is using the so-called legacy configuration mode. There is now a new one, the so-called flat mode, which means your JSON file now becomes a simple JavaScript file. But in the end, it's just maybe a tiny bit of a different way on how you kind of enable the different rules. So in my case, I say I want to add now this new rule, this kind of cyclomatic complexity, and everything that I have to do is that of course, I have to know the name first. It's just complexity in this case. And then I have to turn it on. And I turn it on not by saying on, but I say here error. And with cyclomatic complexity, there are some parameters involved. And there are, as I said before, the numbers in greens, per branch, the numbers increase. The default value, as far as I know, is 20. So I would have to write a lot of code to reach this number. So for the demo, I'm just going to go down a little bit to 2, and then we just see what actually that means. So Since it is enabled now, let's say I create here a simple Angular service. I call it Walker, and it has a function which says go. And I say, you give me a direction, and it could be a union type of north or south, and I am going to return a number. So what I can do now is that I say, well, if the direction, if it is north, then I'm returning +1. And if that's not the case, then I'm just returning -1. So if I save the file, depending on your IDE, but usually the way how it works is that your IDE lints the files upon saving. We see no error, everything looks correct. Looking at the code here from the cyclomatic complexity, we see here two different branches. We have here the first branch, the other one, and since I set number 2, that's fine. But if I would now say, well, it could also be the case that there is an undefined, not a number, but that it is undefined, then I would here come up with a new condition, maybe with a guard in the very beginning, and I say, well, if the direction if it is falsy, and falsy in this case can only mean that it is undefined. So if it's undefined, then I'm just going to throw an error. So I say new error, undefined, not allowed. And if I now save my file, then we see, I mean, it's not really that much highlighted, but we see here an error message coming up from ESLint telling us, hey, look, you have just introduced here another branch. Now we are at 3 different branches, and that's why you exceeded the threshold, and that's why I'm going to throw you now an error, or why ESLint does not allow it. And now I need to find a way on how to fix it. And when it comes to this metric, as I said before, it's kind of really focusing only on a function level, which means if I say here, and that's usually the kind of refactoring technique that I would say is primarily used, that I extract this into an own function. So I say here, yes, this if condition, which I have here, I want to put it now into a new method. Maybe I don't want to call it extracted, but I say here assert not undefined. And once I do that, you see that now from the go, the ESLint goes away because this is a simple function call. It's not an additional branch, and we still end up with 2 different branches. And that's why the refactoring in that case was now successful. And that's the blueprint. So you have different metrics you can choose from. They will all give you a definition on how they work. ESLint, in most cases, will highlight it, and then you need to fix it on the file level, usually by applying common refactoring techniques, as I have done it now. But ESLint is maybe not enough. So if you're really serious about refactoring and also keeping your code base quite sharp, so in a good size, not in a good way, but yeah, you know what I mean, then you also want to use maybe better tools. And there are quite a lot of them. I would say the most popular one is SonarQube. So we see this, that quite a lot of companies have it running. And I think we can also take a look at it just to get an impression how that feels, what the UI shows you, and what kind of metrics we can expect from such a tool. So what I have here is that I took my eternal application. That's an application that I use for all my talks most of the time. And I have to say it's an extremely simple application. Yeah, there is not so much logic in it. Everything is well structured, but there's not so much to do. And this is also reflected if we take a look at the metrics. So we have here the measures. This is SonarQube. I mean, actually it's Sonar Cloud, so I can connect it to a public repository on GitHub. And what I want to highlight, so you have here different categories, and I think the complexity is one that we might want to look at. So we have here our cyclomatic complexity. There's also this cognitive complexity. As far as I know, that's one which comes from Sonar Cloud. I think maybe it's also only exclusively available for Sonar Cloud. I'm not sure. But what it is all about, it tries to be a little bit better than the cyclomatic complexity in that way that it says, if you use some certain shortcuts that the programming language allows you, then maybe we don't see the code so complicated, so complex. And we really try to give you more we really try to measure more the readability of the code, which might not be exactly what the cyclomatic complexity does. With the cyclomatic, the primary focus is more or less how many tests do you actually require to write, because you need to want to cover all of them. And cognitive is really focusing towards more readability. At least that's what Sonar Cloud or SonarQube is saying. Yeah. In that tool, you click just on the metrics. It will show you the directories. You will always get an aggregated number. So in my case, source app, as we know it from a typical Angular application. And then in this case, it says, well, in shared, it looks like there is the majority of your cyclomatic complexity. It's that particular file, the customer's interceptor. Well, yeah, if it is like this, I'd say, yeah, it's a little bit complicated, but in the end, it just mocks the backend. So I would say, yeah, I would kind of agree that it's complicated. It's also the largest file, I think. There's also maintainability. That's also important because it comes with the technical debt where it says, hey, look, maybe I need to go back to the root. It says, hey, look, collecting all those kind of code smells that you have, all those things that you maybe want to fix, I would estimate that it will take you for that particular project 1 hour and 6 minutes. And to the relation of the total amount of your code, that's 0.1%. So the ratio is that. And if the technical debt is only 0.1%, then we would say that's a good rating. That's why we end up here with an A. So you get very quickly a first impression how well maintained or how good for maintainability your code base is. Quickly want to show you other libraries. This is the Sheriff library, which I will talk a little bit later. Yeah, we can do the same thing here again. The Sheriff library, in comparison to my Angular application, contains way more logic, and that's why what you also see here, that the debt takes a little bit longer. Also, the code size is a little bit larger. But I think what's really interesting is what the Angular framework maybe might have. And I have it here as well. And if we take a look at the Angular framework, at the maintainability index, so again, that's the collection, then we see Sonar Cloud would say it takes you 404 days to fix all of them. Nevertheless, given the size of this project, it's still a very low ratio. And that's why Angular has an extremely good rating. Yeah. So this is, and of course you do also have the other metrics as well, but this is what you can usually expect if you want to use tooling next to ESLint, really code quality tooling, which are available. There are also some competitors of SonarQube. I would say they are all in a way doing the same thing, code analysis, and then presenting the results, maybe merging them into some kind of aggregation metrics or something like this. Good. Yeah. This is here about the implementation. So function extracting is exactly what I've done before. You can also simplify code. You can also apply strategy patterns, so just design patterns in order to simplify your code. And of course, if you have some code parts there which you are not using anymore, removing them will also benefit your metrics. Of course, also other patterns are also available. For the verification, I'd say, since we're talking here about refactoring on a file level, I would go with a unit test first. So I have a unit test where I would really test that particular function or the method of the class. And as I said before, the expectation is that I do a refactoring and the function is still working as it was before. So I don't have to change my unit test. I can also do a component test. But the important thing is you don't have to change it. It should still produce the same results as before after you've done the refactoring. That's important. And that's what you have to do when you want to verify it. Because if you don't check it and you're introducing bugs or something else with refactoring, that's not what you want. Good. So that's the file level. And now we would move on to the so-called towards modularity or the module level refactoring. And here, the reason of this kind of refactoring technique is really that you say you wanna or you don't want to have an application, a code base where everything is in a way depending on each other. You want to have a structure, you want to have clear modules, you want to have clear responsibilities, and you want to be able to say this part of this module is encapsulated, cannot be accessed from the outside. And this is one thing. And the other rule is that you say there are also some kind of module, so dependency rules in place where not every module is allowed to depend on another one. And I would say that you have it or you don't have it. So if you don't have any modularity, then I would say before you think even about doing any specific in terms of refactoring, please try to bring in modularity. Do this first, and then you have tooling available, which will also help you in terms of verification, but also will help you a little bit in terms of the implementation. So I have here some tools available. I can so some here are listed. So we have the Sheriff. This is the tool coming from us, from Angular Architects. We of course also have NX, which provides the same possibilities, and then also ESLint itself also has some plugins available, which can also do this kind of modularity boundaries check. And yeah, I would heavily recommend that you choose one of these and that you do then refactoring towards modularity. So I have here some examples. A good approach, and this is what we don't see here, is that you split up your application into multiple features on the one side, and on the other side, you have the so-called shared modules. So shared modules can be used by all features, and between the feature modules, you try that there is no dependency there. So the feature modules should be isolated. And if your application grows, then you want to also group your feature modules. And that's here where we always try to kind of come up with domain-driven design. So we kind of define a group of features belonging together. This could be an own domain, but you can also call it scope. That's the term that NX, for example, is using. But this is kind of a blueprint or a template that you can use. And then, of course, you also have then inside of a scope or of a domain, you also have then further submodules. I don't want to go any deeper here because this is a talk that Manfred did already last week. I just want to say there are different ways on how you can structure your modules inside of a domain. You could say you have only two module types. You have the domains, you have the features, and you have then the infrastructure module. But you can also say, I have here a domain where I want to split my components into a container part and into a presentational part, so smart and dumb components. And then, of course, it becomes a little bit harder to module types because then you need to have the services, the logic, the communication with the backend or the state management in a separate module type. And that's why we have here 4 module types. And then the other one on the right side, we have just 2. Depends on your code base, which path you want to go. In the end, as I said, it is important that you have the modules in place, and it is really important that you use one of these tools because they will, or most of them have an integration into ESLint where you get an error message immediately if you violate one of those kind of rules. Could be encapsulation or dependency rules, which are out there. The Sheriff also has a CLI mode, so you're not bound to ESLint, but yeah, ESLint also works fine. When it comes to the verification, we are not on a file level base anymore. So we really kind of do now create now modules. I'd say integration test here in this case is the way to go. Maybe even end-to-end test if you start from scratch. So if you have no modules and you really start from scratch, then maybe even end-to-end test are there. But yeah, if you have already modules and you want to kind of verify that they're still intact, or if you add new modules, then I would say integration tests that cover maybe a certain feature. And then this gives you the guarantee that this feature is still working and that you didn't kind of damage or introduce bugs during the refactoring. Yeah, and then we have the application level. And these are then the huge refactorings. They are not easy. And they are also not easy to kind of identify or to verify. Let's put it like this. Some examples, Angular specific examples for an application level refactoring. You might say you want to switch to signals. So until now you have only used RxJS, and now you say it's time that I'm going to signals. That will be a huge change. Still, the end users shouldn't see any difference. You can also say you want to now use state management. So using NGRX or any other state management library, or you say for some reason you have identified that your modules are not in the right place. So the cutting of the modules wasn't really successful or was not the way how it should be. And that's why you need to rearrange them. This is also a very huge change. This is a way how you can identify, are there any metrics? Yeah, as I said, it's hard. You could use CodeJournal, for example. So this gives you, or this shows you code places inside of your code base where changes happened quite often. And you could take this as an indicator. So if you have a lot of bug fixes and they always happen in the same module, then you already have a reason why you want to refactor there. Or if you, for example, say you're adding a lot of features and you see that the changes always happen in different domains or in different scopes, then this kind of looks like that, again, the modules weren't cut in the right way and you might want to rearrange them. The maintainability index, I would say, is also a metric for the application level. As you have seen before in SonarQube, it collects all the different code smells which they have. Then there's also the Halstead complexity. What's happening there is that they take the so-called distinct amount of the operators and of the operands, so the variables and what you do with them, and they put them into relation with the total amount of your code that you have. And the more variation you have, of course, the more complicated your code is. And this is, I mean, just roughly what the Halstead complexity is based on. You also then, of course, have abstract metrics. So you can also say we want to do an application level refactoring because we would expect that the general amount of bugs reduces. Maybe we want to improve the velocity, or we always see that we completely miss our estimations because nobody can understand what changes need to be done in a code base. So we also kind of want to clean up, and we think that a certain refactoring would help us here. What is also very important are experience and intuition in these cases. So you need to have some kind of a feeling in addition to understand if this really makes sense or not. Testing, verification in this case, I would say end-to-end tests. So you test the complete application and not just a single feature. Integration tests as well, yes, would also work, but in general, I would say here end-to-end test is really key. Yeah, and before we end, I think I've exceeded already my time quite a lot. When should you do it? Well, file level, you can do it always, preventative. That's so-called Boy Scout rule. So whenever you do a change in a file, you leave the place better as you have found it. You might not even use metrics for it. You just kind of try to improve the code a little bit, or you can also reserve some time in every sprint. That's also a possibility for those larger refactorings. I don't think that they will just go like the Boy Scout rule. For them, you really wanna kind of reserve time for proper planning, of course, also then for the implementation and for the verification. Yeah, and now before we end, something very important. Don't always trust the numbers blindly. I mean, maybe I should there blindly as well, because that's the key here. You always need to understand what you're measuring. So you need to understand what those metrics are trying to tell you and how they are constructed. A very good example is the code coverage. Many people think code coverage maybe comes more from management. This kind of explanation. Code coverage is tests the quality of your test, which is not the case. Code coverage just tells you that this amount of tests, that this amount of code was executed. but it doesn't even tell you if it was tested. It was just executed, and that's it. If you care for code for testing quality, then maybe permutation or mutation tests are the better choice. But code coverage doesn't guarantee you to get better tests. So this is one thing where I would say I have the number in front of me, and yeah, be careful. Just if you have 100% doesn't mean that you have good code quality. So don't trust always the numbers. Always understand what the numbers are trying to tell you and how they are constructed. Now, the question, of course, is whom else should we trust? I mean, we could now say we are developers. We know our code base best. So we should say what should be changed. And here I would also say, don't trust yourself either. And as an example, I don't have here a technical example. I have another one from practical life. So you know how it is with the scale. So I try to weight myself, or always get how heavy I am every day. And well, I'm now at an age, I would say, where when I eat, I don't lose it so quickly as it used to be. And I mean, you gain 1 kilogram, or maybe you gain then a second one. And then, well, you look into the mirror, you don't see any difference, and you say, yeah, 2 kilos, it doesn't really matter. It's not a problem. Then you're getting 3, then you're getting 4. You still don't see any difference. And this is then the danger. You have a subjective opinion you have numbers, but you have a subjective opinion. Maybe you find excuses. Maybe you say, yeah, I'm doing now more sports, so I have now more muscles or whatever. But you have the numbers right in front of you, and you don't believe them because you are lying to yourself, because it's easier if you don't need to change there or anything. Now, in my case, the way how it ended was that I had an external consultant, not a professional one. It was my grandmother. And she used a sentence when she saw me for the very first time, which she never said my whole life. And she said, "You're looking very healthy." And healthy means, in the way how my grandmother sees it, when I'm getting sick and I can't eat for 1 week, I have enough storage to get over it. And that's what she means with healthy. It doesn't mean that I have a good physique or that I'm athletic. It really means that I have too much weight. And you get this from the outside because you are yourself, you're in a bubble, you don't trust the numbers, and you kind of get a subjective kind of behavior where you have to be extremely careful. So in the end, as I said before, don't trust the numbers, don't trust yourself. But in the end, you have a feeling what's wrong, and you should compare this feeling with the numbers. And if the numbers also tell you that this is wrong, then I would say you can trust them. But if you have a different feeling than and it is not confirmed by the numbers, then you have to be careful, because then one side is lying. Could be the numbers from the code coverage, or it could be yourself. But always be careful about this. Good. And here we have the last slide, the summary. So as I said before, we have the file level, module level, application level refactoring, different metrics. Of course, measures are necessary there. For the implementation as well, also different tools. In general, I would say with ESLint, you're always on a good side. And for the verification, if we look at it and if we say we want to do file, module level, and application level, we need to make use of all the different testing categories which are out there. The count goes on.